Okay, good morning once again. Today we're going to discuss another type of multiple linear regression. Well, it's a different type actually, and it's called binary logistic regression. The difference between a multiple linear regression and a binary logistic regression is that kapag multiple, yung dependent variable natin, okay, dependent variable natin is a continuous variable. Continuous siya. Ibig sabihin, it takes on it's a quantitative variable, continuous siya. No? It's a continuous variable. So it takes on, it's a numerical variable, and it can take on decimals. No? Yun ang continuous. Now, for a binary logistic regression, our dependent variable is, as the name suggests, binary lang. No? So it can take on values of either 0 or 1. It can be a factor, can be true or false, yes or no, which will then be converted into 0 or 1 para magamit siya for binary logistic regression. So there are many problems that deal with this. For example, ginagamit sa hospitals to, no? Given certain attributes like heart rate, weight, yung BMI, smoker or non-smoker, they try to predict whether that person has either a heart condition or yung heart condition niya either pathologic na or whatever description. So pag dalawa lang yung factors na pinagpipilian, it's called binary. If it's more than 2, ang tawag na sa kanya multinomial. Okay? Multinomial na logistic regression. So we're going to have an example also of multinomial. So kapag dalawa lang yung dependent variable natin, either true or false, 0 or 1, then it's what we call binary. If it's more than 2, then multinomial siya. Okay. So for this, we're going to use the variable binary. Ito siya, no? Binary CSV. And then so of course you know how to load it, guys. Iba yung function ko dito. And let's just use the name dot para pareho tayo. No? So let me just clear all the drawings again. Close this. And then let me just use okay, import database. From text. Okay, let me go to where I saved it. I saved it here. R projects. Where's my R projects? Here. Inside logistic regression. Okay. Then I'm going to use the dot. Let me replace the name with dot so that it's the same as this one. Okay.
Sir?
Yes?
I don't think na-post mo yung CSV file, yung data file po yung Excel.
Ay, hindi pa ba? Wait.
Yung R lang po na file yung meron. Yung, ito po,
Itong binary?
sa modules.
Oh, nasa Canvas. Sorry.
Akala po nasa files. Thank you, sir. Andito na pala.
Okay, sige. Thank you. Okay, wag niyo muna i-click yung strings as factors. Tayo na lang maglalagay niya, no? So import na ako. Okay na ba? Yeah. The file is shown here. And input. We can see the code in the console. No? Let me copy this. Control C. Let me copy it here. Tanggalin ko ng view. Okay. So I have uploaded the file. We called it that. Okay. So let me show this. Yeah. So please chat, guys, if you have uploaded the file. Okay, thank you, Willie. Okay, thank you, you. Okay, let's wait for the others, guys. If class, if you're done, kindly chat so that I know when to proceed. Thank you, Samir. Mariel, salamat. Thank you. I think two more have not yet uploaded the file. Jeff, thank you. Okay, sino pa ba? Really Steph, okay. All right, good. Okay, so let's take a look at the file first, the data. So we have 4 variables dito, ano? Admit, yan, 0, 1. 0 means hindi siya na, so 0 means hindi siya na-admit. So apparently these are 400 respondents of college applicants no, sa isang school. So meron ditong admit. This is a record of the school kung if the applicant was accepted or not. And then ito yung grade ng GRE, GPA ng high school niya, at saka rank ng school. So GRE is, I think this is a parang aptitude test, parang SAT. So the higher the score, the better, of course. GPA, so GPA, parang Lasal, ano din to, Lasal system, 4 yung highest. Okay, and then yung rank ng school, ng high school. So what they did was to rank the high schools into 1, 2, 3, 4, 1 being the highest and the 4 being the lowest. Okay. So the objective here is to come up with a model that will, given the GRE, GPA, and the rank, it will predict if the student will be accepted or not. So gagawa tayo ng model para malaman natin kung matatanggap yung estudyante, yung applicant or not. So our dependent variable is admit. And as I mentioned a while ago, class, our dependent variable is a binary variable kasi 0 or 1 lang. So actually we can use multiple linear regression here kaso the results will not be good. Okay, hindi magiging maganda yung results. Kaya nga, ang ginagamit dito is a special form of regression. It's called binary logistic regression. Okay, so let's go back to our RMD file. Okay, let's take a look first at the structure of our data. Tingnan natin. So data frame siya. Now, if you can see, admit is an integer, GRE is integer, GPA is a numeric, no? And rank is an integer. So we know that yung admit dapat hindi ano yan, dapat admit should be factor dapat yan kasi classifier yan. And so is rank. So we're going to convert this. Si admit at saka si rank, dapat factor siya. Hindi naman talaga number tong rank eh. It's a classifier, no? Rank 1, rank 2, rank 3, rank 4. These are classifiers of the student's school where he or she came from. Okay. So let's here class, let's convert yung admit as a factor. So you know what this does, diba? So let's run this too. Si that, si admit at saka si rank, i-convert natin as factor. Pag hindi natin gawin yung class, the model will not work. No? Okay. And then let's try to see again the structure. All right. So factor na sila, no? Admit is now a factor. Rank is now a factor. So we can now proceed with the regression. Okay. Let me pause for a while. Okay. Okay, kindly chat please. Class, if you're okay so far, kung nakahabol dun sa pag-convert ng mga variables natin into a factor. Okay, thank you. Thank you. Samir, Mariel, thank you. Steph, salamat. Billy, thank you. Sam, thank you. Jeff. One more.
Sir, may problem po sa akin.
May problem? Sino to you?
Opo, sir.
Sige. Let's take this opportunity to sige, would you want to share your
Sige po, sir.
sige. Share your screen. Stop share ako.
Ayun po.
Stop share ako. Sige. Thank you for asking the question. Class, I hope you do the same pag may mga questions, ha? So let's see. Anong problem? Cannot open the... Okay. Anong ginamit mo, you?
Yun din po, sir. Yun that.
Hindi to pa pwede, kasi read.csv hindi natin identify yung ano mo. Sa import ka pumasok, import dataset. Did you do that?
Yes po, sir. Ito na ba?
Wait. Sige. Okay. Pinalitan mo ng pangalan.
That po, sir.
You changed the name already. Kasi binary binary kanina yan, di ba? Asan yung binary file na ano?
Yun pa yun, sir.
Ayun na yun. Sige. Okay na, gawin mo ng dot. Okay na yun. Okay. So import. So, yun na. Okay. Yan na tayo. Good. Tapos, wag mo na i-run yung yung dot na yan.
Okay.
Don't run that anymore. So punta ka na sa structure. Sa 30, row 30. Yan.
Okay na po, sir.
Okay na. Sige, tapos ano mo na as factor. We did not run anymore yung dot, no? Dapat tinanggal ko na lang yan. Kasi nasa machine ko yan eh. Iba yung sa machine yun.
Sige,
Okay?
sir. Thank you, sir.
Sige. Thank you for that question. Very good. Appreciate the questions, no? Class, ganun na. Ganun tayo. Napakaliit ng klase natin. So, I want you to really be, huwag kayong mahihiya magtanong. And thank you for that question. Okay, so clear tayo so far. Now let's take a look first. Okay, ito class, this is what we call a two-way table. No? X tabs, cross tabulation to. Okay, so cross tabulation gives us a two-way table ng ito, admit at saka rank. So gagawa siya ng cross-sectional table. Let's run this. Okay, so tingnan natin, no? So ito yung data natin. Admit is 0 is not admitted. 1 is admitted. Tapos ito yung schools, no? 1, 2, 3, 4. So we can see here that for rank 1 schools, 28 were not admitted, 33 was admitted, no? So more than 50% ang sa rank 1 ka, more than 50% chance na matanggap ka. Pero dito sa rank 4, very low yung percentage, 12 admitted, 55 were not. So that's out of 12 out of 67. So tingnan nga natin. 12 divided by 67. So only around 18% from rank 4 schools. Ano naman, pag rank 3, 28 divided by 28 plus 93. 23% lang yung natatanggap. So the lower the rank, sa about rank 2, it's 54. 54 divided by 97 plus 54. I'm just getting the percentage of those that were accepted. So sa rank 2, mas mataas compared to rank 4 and rank 3. 36. But rank 1 really outranks them all. No? 33 over 28 plus 33. Okay? So 54%. Pag rank 1, ang probability na matatanggap ka 54. Pag rank 4 ka, just 18%. All right. Now, may I ask you a question, class? Did we do partitioning last time? Nag-partition na ba tayo? Kindly chat please, or this will be the first time na magpa-partition tayo. Do you recall, guys, kung nag-partition tayo? Okay, sa Samir, no. Okay, sige, thank you. All right, so I'm going to teach you something, a skill that is really used in practice sa data science. What we do is we don't really use all our data set. No? 400 lang observations natin. Pag ginamit natin lahat ng data na to, itong 400 responses, pag may, if we're going to use this to model yung admit natin, to come up with a model that will predict admit. Tapos pag may mga bagong data tayong gagamitin, it might not work well kasi yung our model was derived using the 400 responses. So we might have a model that's what we call overfitted. No? Overfitted yung model natin. So what's done in practice is that pinapartition natin yung data natin. Okay, we split it. So this is what we do. We partition the data, okay, into 2 sets. No? Sa iba ang ginagawa 3 sets. Sa atin 2 lang kasi konti lang data natin, 400 lang. So we're going to partition it into training data and then testing data. So what we're going to do is yung training data natin, yun ang gagamitin natin to model our binary logistic regression. And then when we come up with the model, we're going to use the test data to see if our model still works well. Okay, so that's what we're going to do now. Now, ang usual na ratio na ginagamit, depende sa size ng data natin. Some would use 70-30, 70% dun sa training data. Yung iba 75, 75-25, or 80, 80-20. Depende dun sa size ng original data natin. So here, we're going to split our data into training data and testing data. Ang training data na gagamitin natin, 80% of the data, and then testing, 20%. Okay, I think I mentioned to you before yung set.seed. No? So set.seed allows us to generate random numbers. Tapos maglalagay tayo ng number dito na pare-pareho tayo para so that we have the same random numbers generated. Okay, so take a look at this function yung susunod. So we're creating this object called ind. No? Okay, this is just refers to index. No? And then we're going to use the sample function. So let's check first nga muna yung what the sample function does. Let's check this para alam natin kung ano yung okay. So rinan ko siya dito sa console natin, and the sample function comes from the trees. Okay, so what does this do? Sample takes a sample of the specified size from the elements of X using either with or without replacement. So this is the syntax. Sample, okay, X. What's X? a vector of one or more elements from which to choose, or a positive integer. Okay? So, ibig sabihin niya, mag-sample daw ng sa atin, dalawa. No? Kung dalawa gagamitin natin. That means that our data will be split into two. Okay? Ano yung size ng data natin? Ilang observations? And then replace is equal to false or replace is equal to true. The default is replace is equal to false. Okay? And then probability, ano yung division natin. Okay, so this is the syntax. So prob is a vector of probability weights for obtaining the elements of the vector being sampled. Okay, replace, should sample be with replacement or without replacement? Yung with replacement class, kanyari, we draw out one number from the sample. Pag with replacement, ibabalik yung number na yun. Pag without replacement, pagkuha sa kanya, hindi na ibabalik yung number na yun. Okay, so you're going to use it only once. The default is false. Okay, so we'll use replace is equal to true. So pwedeng isang sample, pwede makuha ng twice. No? Okay, so this is our syntax. We're creating this object in. We're going to use the sample function. We're going to split our data into two. The number of rows natin is n row dot, di ba? That is our object. So instead of writing 400 kasi 400 observations tayo, di ba? Sorry. Yung pala ako naka. Okay. Back here. Okay. Instead of just writing 400, ito, ginamit natin yung function na n row. Okay, this will give us the number of rows, number of rows of our data set of that. And then replace is equal to true. If we don't put anything here, replace is equal to false. Yun ang default, di ba? So ito default to. Replace is equal to false. And then probability is equal to 0.8 at saka 0.2. So we're splitting our data into 80% and then 20%. Okay. So let's run this together first. Okay, and then nga pala ito. So we're going to create now an object called train. Okay, so itong train na to, okay, we're going to use our data dot and then i-index natin lahat ng may index is equal to 1 pupunta kay train, lahat ng may index is equal to 2 pupunta kay test. Okay, so let's run this first, no? Yung first two muna para makita nyo kung anong nangyayari dito, no? So let's run this. All right. So let's take a look at the end object. Okay, so dapat nagka-end object kayo, no? I-run nga natin tong end na to. Let me see. Okay, view end. Okay, so it's an integer containing 400. Okay, dito na lang. No? So let's take a look at head ng end. Doon natin first 20. Okay, so these are the first 20 elements of the object end. Saan ang galing si end? Si end, create natin by getting a sample. No? Sample ng dalawang sample. No? Dalawa. Okay. Para i-split niya yung data natin yung dot into 2. So ito 1 1 1 1 2 1 1 1 1 1 1 2 etc. Okay. Then let's go here now. Let's create this object called train and test. Ang laman ni train kasi ito si dot, di ba? So what happened here was si dot, it was split into 2. Okay? May mga 1 dito. So yung first element na to, this is 1. 1, 2, 3, 4, 5. So this is 1, 1, 1, 1, 1, and then yung number 6, 2 na, no? So, we're splitting our data dot into 2, and ni-number siya into 1 and 2. Lahat ng number 1, papasok siya dun sa, based on our code chunk here, ito. Lahat ng number 1, pupunta ka siya kay train. Lahat ng number 2, pupunta ka siya kay test. So let's do this. Okay, so we now have test and train. Okay, so take note, test is 75 observations. So approximate lang yung ano, no? Kasi 400 yung sample size natin dun sa dot times 0.8, 80%. So that should be 320. So dito lumabas na 325. So hindi eksakto yung split ni sample, no? But it can be done yung eksakto, but let's do that next time na lang. So 320 tapos si train 75 observations. So let's take a look at our train. Okay, what do you notice about our train data set? So si train data set 325 na lang, no? Okay, so sino kasama sa kanya? Take a look at the rows. Row 1, 2, 3, 4. So nawala si 5, di ba? Wala na si 5 dito. Bakit? Kasi si 5 was classified as number 2. So random tong pag-classify na to. Tapos class dapat pare-pareho tayo . So kindly check. Walang 5, walang 14 kasi dito yung number 14. Tapos walang 16. So let me pause for a while and could you kindly chat class if we have the same train data set? Si train data set, nawala si number 5, nawala si number 14, nawala si number 16. Saan sila napunta? Napunta sila sa U, meron pa rin sa U. Sige, check natin yung stop share ako. U, kindly share your screen again. Let's see. That pa yan, U. That's the dot data set. Naran mo na ba yung ano? Sige, punta ka sa environment. Sa baba, sa environment, sa baba. Hanapin mo si train. Scroll bar mo pababa. Yan, si train. Sige, yan si train, di ba? Letter T. Yan, sige, click mo siya. Ayan. Okay?
Okay,
Diba?
sir.
Wala na number 5, wala na number 14, wala na number 16. Take a look at your test. Buksan mo yung test mo. Sige, well, we're at it. No? Dito, sa baba, sa environment. Yan. Click mo siya. Okay. Okay, take a look at, class, take a look at use train data set, no? So yung train data set niya, ang laman lang, si test pala. Si test. Si 5, 14, 16, di ba yung mga row numbers na to? Di ba? 75 na lang siya. So what happened? Ito yung in-split natin, no? Using the sample function. We split our data into training data and testing data. Okay, so what's the purpose of this? The purpose is we're going to model yung train. Tapos, pag na-model na natin, i-run natin si test dun sa model natin to see if effective pa rin yung model natin. Okay? Did that answer your question?
Yes po, sir. Thank you po, sir.
Sige, okay. Thank you. Alright, back ulit ako sa pag-share. Okay, so I hope you checked yung test at saka yung train data set natin. No? So medyo medyo na-split na natin yung data set natin. So let's go here. So now, let's continue now our regression. So una, let's create this. Let's call it my model. You know this, right? LM. Tingnan muna natin to, no? LM, okay? What happens when you regress admit on the independent variable using the LM function? Let's take a look at this. Admit yung dependent variable natin, and then our regressors are GRE, GPA, and rank. And then take note, we're going to use the trained data set. Okay? So, alam niyo na to, no? Class, yung LM. Alam natin yung LM function na yan. And then, i-summarize natin. Sige, let's run this. Okay, let's see what happens. Okay. Did you get this? Did you get this notation? Cut na, please. You got the same notation? Okay, very good. Now, what does it tell us? Kasi si admit factor to, di ba? Factor siya. Tapos gagamitin natin as yung variable na factor and regress natin dito sa mga predictors natin. So, mag-warnings are hindi pa pwede. No? Hindi pa pwede na yung sa LM function natin, linear model, hindi pa pwede na yung predictor natin, yung dependent variable natin, is a factor. Dapat yan, continuous variable yan. Kaya last time, yung nag-regression, di ba? Wage. Yung wage, okay yan kasi continuous variable yan. Decimal yan, numeric. Itong admit, hindi. So mag-error siya. Okay? So what we're going to use, class, is a new family of functions, GLM. Okay? So si GLM, yan, generalized linear model. Okay? So kapag binary logistic, pag multinomial, and other forms of regression na specialize yung ano natin, yung dependent variable, you use GLM. Sige nga, tinan natin GLM. Ano muna natin, i-start tayo para alam natin, class, kung ano yung ginagawa natin dito. Alright. Okay, so this is from the stats package also. Fitting generalized linear model. GLM is used to fit linear models specified by giving a symbolic description of the linear predictor and a description of the error distribution. Okay, so let's take a look at the generic function. Ito yung formula. Family is equal to, yan, Gaussian. No? So sa family, dito nagkakaiba. Gaussian, okay, if you notice, may iba-ibang mga ano pa, parameters. So let's take a look at the family. Okay, a description of the error distribution and link function. So yung GLM, gumagamit siya ng link function. Okay, for GLM, this can be a character string, okay, a family function, or the result of a call to a family. Okay, tingnan natin tong family. Ano ba tong, let's take a look at the details here. Ayan. So, class, ito yung link niya, no? Link function. So, andyan si binomial. Okay, andyan si Gaussian. Andyan si iba't ibang klaseng functionalities. Gamma, inverse, Poisson, quasi binomial, quasi Poisson. So, if the functionality is of this type, hindi natin pwede magamit si LM. We have to use the generalized linear model. Okay? So, any questions so far? So, clear tayo kung bakit GLM yung gagamitin natin. Generalized linear model. Okay, so pause muna ako. Clear? Clear ba, class? Kung kunyari pag binomial or Poisson distribution yung ginagamit or inverse Gaussian. Okay, thank you. GLM dapat yung gagamitin natin. Okay, so nakita natin na kapag LM gamitin natin, mag-error tayo. So we have to use the generalized linear model. So let's do this now. Okay, let's create this mod X. Mod X tong pangalan, baguhin na lang natin yung pangalan. GLM admit regressed on on your, ito yung model natin. Okay? Then we identify the data, still train data, and then ito na iba. We have to identify the family. So pag GLM, we have to define kung anong family siya, kung Poisson ba siya, kung Gaussian, etc. So let's run this. Okay. All right. So the output is the same, no? Andiyan pa rin yung call ng formula. Okay. Now, medyo na iba to, no? Hindi residuals, deviance residuals. And then the coefficients are this one. Coefficients. So we have the intercept, we have GRE, we have GPA, and then alam naman natin yung mga ranks, di ba? Rank is a factor, so ang ilalabas diyan, idadamify na ni ano yan, ni R, no? So rank 1 is the benchmark, okay, which means that all of these are interpreted relative to rank 1. Siya kasi yung benchmark natin, no? Siya yung ginawang 0. And you see, class, di ba? We have 4 levels, rank 1, rank 2, rank 3, rank 4. So there are 3 dummy variables. No? Tatlong dummy variables, naalala niyo yun? It's always the L minus 1, the number of levels minus 1. So nag-generate siya ng tatlong dummy variables for rank 2, rank 3, rank 4. And then when you interpret this, it's always interpreted in relation to the benchmark, which is rank 1. Okay, so you notice that the intercept is significant, GPA is significant, GRE is not significant. So si rank 3 and 4 ang significant. Pero kahit na hindi significant si rank 2, kailangan pa rin natin isama yung rank as a predictor kasi we have two levels that are significant, no? Si rank 3 and rank 4. Okay. Okay. Now, you can also, of course, you can include si rank 1 as a level, no? But in order for you to do that, kailangan magtatanggal tayo ng intercept. So dito, kasama yung intercept, pero mababawasan ng isang rank. But if you prefer that rank 1 will be included, kung gusto niyo kasama si rank 1, that can be done, but the intercept has to be removed. If you recall this, kaya nga, ang gagawin natin dito, so I'll call this M1, okay? GLM, admit, regress on all, di ba? Ibig sabihin itong regress on all, pero may minus 1 dito. Yung minus 1 dito, ibig sabihin, tatanggalin yung intercept. Then data is equal to train, family is equal to binomial. So let's run this and see. You'll have the same result. Okay, pareho lang naman yan. Yun nga lang, ito, okay, notice na andyan dyan si rank 1. Okay? GPA is still significant. GRE seems that it's not significant, no? Kahit dito, hindi siya significant. Tapos yung mga ranks, yan, kasama lahat ng ranks. Okay, so that's an alternative, no? Ang kagandahan nito, class, is that when you interpret this, diretso na. For rank 1, for rank 2, hindi na natin i-benchmark yung interpretation. Kasi kasama na lahat ng levels. Okay? So what happened was, yung yung intercept na to, actually, pinasok yan dun sa ranks, no? So for example, si rank 2, -0.57. So medyo nag-konting difference, ano? 6.13, 6.54. 6.13, 6.54. So medyo naiba, no? Naiba kasi yung relative effect niya dun sa rank 1 was already accounted for. Kaya naiba na yung no? Naiba na yung mga estimates dito. Okay. All right? So we saw that the significant variables are GPA and rank. GRE is not significant. Okay, di ba? GRE is not significant. So our model is not yet finished. Remember yung stepwise regression natin. Now, since iisa lang naman yung independent variable na hindi significant, yun lang yung tatanggalin natin. No? That will be our leaving variable. Only one. Only one. Si GRE lang. So, let's remove GRE from our model. So we will now have, let's now call this mod. Binago ko na lang mga pangalan. No? GLM, admit, regress on GPA and rank. So dalawa na lang sila. We remove GRE as a predictor. So data is equal to train, family is still binomial. So let's run this. Okay. So again, you have your deviance residuals. And then, okay. Okay, so sinama natin intercept dito, no? Or let me copy this again. Another way to do this. Control C. Okay, we can put here -1. No? Okay. -1 to indicate that it's removing the intercept. No? So run natin to. Okay. So nawala na yung intercept natin dito. Okay. GPA at saka lahat na lang ng ranks. Okay, either way, class, you get the same result. Okay. Mas madali nga lang yung interpretation nito kasi tuloy-tuloy na. No? Dito, medyo magkakaroon ka pa ng konting computation. Kasi dapat compute natin kung paano yung for example, ito, no? How do you compute for rank 1? Paano natin i-compute si rank 1? Okay, let me just illustrate that quickly. Okay, run ko itong mod, no? And then dapat nag-mod 1 ako dito para iba yung pangalan. Let me call this mod 1. Okay? Okay. Let me just illustrate. Kasi, kunyari, si rank 1, ano yung estimate niya, ano yung intercept niya? Di ba rank 1, what's rank 1? Okay. What's rank 1? Let me start with intercept. So ano si intercept? Si intercept is the value of your variable of interest, si admit, if all the parameters are equal to 0. So ibig sabihin, si GPA 0, rank 2 0, rank 3 0, rank 4 0. No? So that will be your your rank 1. Di ba ganun yung interpretation niya? Si rank 1, ang estimate niya will be, si intercept pala, ang estimate niya, it's the value of your GPA if all of these are all 0. So pag wala tong GPA na to, wala si rank 2, wala si rank 3, wala si rank 4, the value of your GPA admit is negative 4.72. Okay? Di ba? Pero, if you recall, pag walang GPA, walang rank 2, walang rank 3, walang rank 4, sino yon? Sino yon? That's rank 1 actually. No? Kasi hindi rank 2, hindi rank 3, hindi rank 4. So, sino siya? Si rank 1 siya. No? So, si rank 1, kaya nga yung ano yan dito, yung intercept niya dito, yung slope niya 4.72, which is actually your intercept, no? So I hope you noticed that, no? Kasi, let me repeat that one more time. What's the intercept? Intercept is the value of your admit, no? If all your predictors are zero. So si GPA, 0, rank 2, rank 3, rank 4. So kung hindi si rank 2, hindi si rank 3, hindi si rank 4, sino yon? Si rank 1 yon, no? Because rank 1 is the benchmark variable. So rank, yung negative 4.72 na to, that's the value of rank 1 when your GPA is 0. Tapos, yeah, when your GPA is 0. And that's the value now. Ito yung rank 1, 4.72. Okay? So, I hope clear yon, class. Okay, so let's go now. Let's run this. Okay. Yan. Okay. So, alright, bakit may square dito? Dapat walang square to. Kindly, dapat walang square to, class. No? Bakit siya na square? Wait lang. Okay, correct, class? Okay. Sorry for the error dito. No? Okay, so yung equation natin is y is equal to beta null plus beta 1 x11. Okay, di ba this is our generic regression, di ba? Tapos yun yung output natin dito, no? So let me use itong usual. Ito. Okay. Now, when we do GLM, when we do binomial regression, medyo iba yung interpretation nito. No? The y value there is not your admit. Okay? Hindi siya yung admit. Ano siya yung log odds ng admit? Take a look at this. No? Log odds ng admit. So when you're interpreting yung result ng binary logistic regression, it's not like yung sa regular regression na, okay, for every 1 unit increase in GPA, there's a corresponding 1.337 units increase in admit. Kasi yung admit yung ano natin, di ba, yung dependent variable. So that's not the way to interpret this. Medyo iba yung interpretation niya. Hindi yung ganung for every 1 unit increase in GPA, there's a corresponding 1.3735 units increase in admit. Kasi yung admit natin dyan is of this form. No? Ang tawag dito, log ng odds ratio. So where did that name come from? Okay, una yung odds muna. Notate na lang ako. So yung odds ratio, okay, you call it odds ratio. Odds ratio is the probability of happening, okay, over, okay, odds ratio. No? So ratio siya, alam natin na you're getting a division, no? The probability of being accepted P over 1 minus P. Okay. So here we're dealing with ano probabilities kasi. Ang gusto natin malaman, maa-admit ba siya or hindi siya maa-admit. So we're dealing with the probability of being admitted vis-a-vis the probability of being not admitted. So this is called your logs ratio. So yung y natin dito sa equation natin ito, it's not your usual ano na yung sinabi ko kanina no, for every 1 unit. Hindi natin in-interpret yung mga betas sa ganun. Okay, it's interpreted okay using this. So this is your odds ratio and then you get the log of that. So ln natural logarithm no, or log to the base e. So your y is the logs ratio. Okay? Ito yun. So this is what differentiates it from the usual multiple linear regression. Ang tinitingnan natin dito is the log odds ratio. Okay, let that sink in for a minute, no? Para medyo klaro sa atin. Okay? So once again, class, I hope this is clear. Yung equation natin ng y admit, it's not equal to yung usual na ano, yung usual na ganito, no? It's equal to the log odds ratio. Okay, so dapat ano pa natin, i-simplify pa natin to, no? So it's not just pag multiple linear regression, diretso na yung interpretation natin kung ano yung marginal impact ng isang regressor, yung beta natin, ano yung effect niya on y, no? So we learned how to interpret that, di ba? For every 1 unit change in your variable 1, there's a corresponding beta units increase in your dependent variable. For the GLM, family binomial, iba yung interpretation niya. Okay, so let's proceed first. No? Oops, let me delete. Okay. Okay, so take a look at this. No? Log odds. Yung y natin, yung admit variable is equal to log odds, which is equal to beta null plus beta 1 times x1, etc. No? Okay, so if we're going to substitute, y is equal to log odds is equal to beta null plus beta 1 times GPA plus beta 2 times rank 2 hanggang rank 4. Okay? So ang question, how do we interpret the results? Okay, so sabi natin, so pag in-interpret natin si GPA, we're going to use the log odds kasi yung y na to, as I said, and I hope I'm not sounding like a broken record already, yung equation na y is equal to log odds. So when we interpret GPA, so dapat sasabihin natin na for every 1 unit increase in GPA, okay, the log odds of being admitted increases by 1.3735. Okay, so that's how you interpret it. For every 1 unit increase in GPA, the log odds. Okay, the log odds ang ano natin, no? Kasi si y is log odds. The log odds of being admitted increases by 1.3735. However, ang hirap i-interpret ng ano ng log odds, no? Log odds is difficult to interpret, but we can derive the odds ratio, which is a lot easier to interpret compared to the log odds. Okay. Now, ano nangyari dito? Ang nangyari dito is kinonvert natin. Okay? Hindi pa. Wait, ha? Okay, sige. Let's continue first, no? we're going to learn how to interpret this. Okay. Log odds is difficult to interpret. However, we can derive the odds ratio, which is a lot easier to interpret compared to the log odds. Wrong spelling. Okay. So from this one, di ba? Y is equal to negative 4.72 plus 1.375. Ito yung equation natin, di ba? Saan ang galing to? Where did this come from, class? Where did this equation come from? Anyone, please? Where did this equation come from? Class? Anyone? Saan ang galing yung ano? Saan ang galing yung number niya? Negative 4.72 plus ano?
Sir, I think the numbers came from the model we created.
Yeah, correct. Thank you. That's right. Huh? Thank you, Samir. That's correct. Yung numbers yan, galing sa model natin. Diba? Ito. So y, which is your admit, diba? Yun ang dependent variable natin, is equal to negative 4.72 plus 1.375 times GPA plus negative 0.57 times rank 2, etc. Yun yung model natin. And take note, remember, that y is equivalent to something. And that something is your logs ratio. Ito yun. Log ng P. P is the probability of being accepted divided by 1 minus P, which is the probability of being not accepted. Okay. So let's continue. So, okay. Let's do this, no? We will solve, let's solve for y. Let's solve for y. Let's just use the first individual. So going back here sa data natin, sa train pala natin, ano? Sa train data natin. Ito yung first sample, no? You have GRA is equal to 380. Wala na palang GRA, ang tinanggalan natin, no? GPA na lang 3.6 at saka rank 3 siya. Okay? Rank 3 siya. So, if we compute for that, so let me do it here. Okay, see, dito na lang, guys. Ito na lang, no? So, ito yung model natin. Do we know the GPA? GPA for sample number 1, 361. So, i-multiply natin si GPA, yung slope niya, 1.3735 times 3.61. Okay? And then, rank 2, why did we multiply here by 0? Sige nga, class, why did we multiply by 0? Anybody, please? Class, why did we multiply by 0?
I think, sir, because we're computing for rank 3, which is why rank 2 and rank 4 are marked 0.
Yes, correct. Thank you, Samir. That's true. Kasi, class, diba yung unang observation natin, we are computing for y, the log odds of the first observation. So sa model natin, we're going to substitute these values except for GRE kasi tinanggalan natin si GRE. GRE is no longer part of our model. So rank 3 yung first observation natin. So this 0.57, negative 0.57 is for rank 2. So di naman siya rank 2 eh. Tapos ito, negative 1.1645 times 1. Okay, tama. Papasok to kasi rank 3 siya. And then ito na naman, times 0 na naman siya. Okay? So there you go. The value of y for the first observation. So yung unang-unang observation, ang value ng y natin is negative 9.33, which is equal to the log of log odds ratio. No? Okay? Ngayon, ang gagawin natin, kasi gusto natin malaman yung probability. And what's the probability that the person, number 1, will be accepted? And how will you know that? We solve for P. No? Kasi ito negative 0.933, that's your log odds. So what's the log odds ratio of observation number 1 being accepted? Negative 0.93. But how do you interpret that? Ang gusto natin malaman, ano yung probability na matatanggap siya? Hindi yung ano yung log odds ratio na matatanggap siya. Okay? Pause muna ako guys. Clear ba yung concept na yun? What we want to know is what's the probability that observation number 1 will be accepted? Okay? Do we have that? No. Anong meron natin? What's the log odds ratio that number 1 will be admitted? Yun, negative 0.933. Ito yun. Diba? This is your y. Diba? And remember, your y is your log odds ratio. So how do you interpret this? The log odds ratio of number 1 being admitted is negative 0.933. But we said that it's difficult to interpret this, so we can compute for your P, which is the probability of being accepted. No? Sige, so let me see. Open na lang ako ng Word file. No? Sana mabilis mag-open. Kasi gusto kong, I want to show you how this is interpreted. We have to know how this is interpreted. Let me just open my digital pen. Okay. Sorry about that. Okay. I hope my digital pen works. Hold on, guys. No? Okay. Okay, so we have y, diba? Y is equal to log. Okay. Yung log dito, natural logarithm to, no? P over 1 minus P. So this is our log odds ratio. Ito yung na-solve natin kanina, yung negative 0.933, di ba? Tapos sabi natin, ang hirap i-interpret nito. So ang goal natin, hanapin to. So we already know y. If we can solve for p, then okay tayo. No? So from your previous math, I hope na ano nyo, nagawa nyo, no? How do you remove the log? The log can be removed by getting its inverse function, yung exponential, no? So e to the y, okay, is equal to e to the log of p over 1 minus p. Okay? So by getting the exponentiation of both sides, what will happen now is this will cancel out. Okay? Yung e at saka si log magka-cancel out kasi si exponentiation at saka si log, they're inverse functions. So we have now e to the y is equal to, so matitira na lang dito p over 1 minus p, di ba? So masisimplify na natin. No? So we will now have e to the y times 1 minus p is equal to p. Transpose lang natin si 1 minus p. So we now have e to the y, distribute natin, minus e to the y times p is equal to p. Okay? So we're interested in solving for p. So this becomes e to the y is equal to, we transpose this to the other side, p plus e to the y times p, right? Which is equal to p times 1 plus e to the y. We factored out p. Therefore, kulang pa to, p plus, ay, sorry. Ito na to, no? Finactor out natin si p. Yan. Therefore, p is equal to e to the y divided by 1 plus e to the y. There. Okay, so that's your computation to solve for p given your y. Okay? So, pag alam natin si log odds ratio, si y, mako-compute natin si p. Okay, so please take note of this equation. No? P is equal to e to the y over 1 plus e to the y. So let's go back to our R. Okay. All right. So ito, no? Kaya let me see kung sa annotation kaya ba dito yung ano. Okay. This will work also. So yung equation natin, probability, the probability is equal to e to the y over 1 plus e to the y. Okay. We know already y. No? Na-solve natin dito yon. Yung y natin kanina yung negative 0.933, di ba? Ayaw. So negative 0.933. So ito yun. Yan. So we can now compute for the p. So which is equal to, p is equal to e to the y So ang function yan, exp, exponential, no? Over 1 plus e to the y. So that's how we compute for your e. Okay, and then it turns out to be 0.28223. Sige nga guys, pakitry sa console, i-type nyo exp and then you get the exp of negative 9.33 divided by 1 plus exp of negative 0.933. Please, hindi ko lang magamit muna yung mouse ngayon kasi naka writing pen. And then tell me what you get, please. What value do you get for your p? And paki-chat, please. Are you getting 0.282283? Okay, good. Thank you, Willie. The rest, I hope you got 0.28233. You, thank you. So let's wait for your classmates. Tingnan natin kung they got the same. The other 6, class. Samir, thank you. So 5 more. Steph, thank you. Good. Sam, thank you. Good. Jeff, salamat. Okay. So 2 more. Sino pa bang si Mariel, naka-ano na ba? Mariel, were you able to get it? Okay, thank you. Yan. So lahat na ba? I hope guys, everybody got it, no? So let me stop ko na muna to. So what I was requesting you to do was to ito, no? Actually, ito yun. So why are we doing this, class? We're doing this kasi it's so difficult to interpret yung log odds. And that's what we get from the equation yung y is equal to, no? So what we do is to convert this into probabilities para mas maano natin, para mas madali natin ma-interpret. And we're getting 0.28. So this is the probability that person number 1 dun sa trained data set natin will be accepted. So this is below 0.5. So the probability that number 1 will be accepted is 0.28 based on our model. And if we take a look at our model, yung train natin dito, person number 1 was not accepted. So sa first data set natin, okay yung model natin. Okay? Okay yung model natin. Okay. So let's as an exercise class. Let's do that for person number 2. So kopyahin natin yung model natin dito. Ito, no? This one. So let's copy this. Kindly do this now, class. Control C, Control V. Okay? And then palitan natin yung ano, kung rank 2, rank 3, rank 4. Okay, palitan natin guys and solve for the log odds ratio. And then solve natin probability. Okay, so let's take a look at person number 2. Ano GPA niya? 3.67 at saka rank 3 siya, no? Okay, so let's do that. GPA niya is 3.67. Rank 3 siya. So this becomes times 0. times 1, and then times 0. There. Control Enter. All right, I'm getting negative 0.85. Okay, sige nga. Class, paki-chat if you got the same. Kindly chat, please, if you got negative 0.85755, which is the log odds ratio for observation. We'll wait for your feedback. If you were able to get the log odds ratio of person number 2 in the trained data set, equivalent to negative 0.850755. Okay. Thank you. Thank you, Willie. Thank you, Marielle. So let's wait for your classmates. Here, thank you. And very good. So we have 5 more. Yung, thank you. Steph, thank you. Sam, Jeff, yeah, very good. Okay, I think, I hope everybody got it. All right. You, thank you. Yan, kompleto na tayo. Now, remember, class, this is log odds. So, ang hirap natin i-interpret niyan. So, let's convert that now to yung probability, which is EXP. Okay. Take note of the formula, guys. E to the y, di ba? Ito, no? E to the y over 1 plus e to the y. So, this is our y. Okay. And then divided by 1 plus e to the y. Okay? So yun, e to the y over 1 plus e to the y. So that's now your probability. P na yan. And I'm getting the answer of 0.299. Okay, again, kindly chat please if you got 0.299. Good. Thank you, Willie. Thank you, Samir. Okay. You, thank you. Yes, salamat. Very good. Okay, good. Thank you, Marielle. Steph. Okay, kumpleto na ba? Okay. Yung. Yan. Thank you. All right. So 0.299. This is less than 0.5. Kasi ang cutoff natin pag binary logistic, kapag less than 0.5, 0 yon. Kapag 0.5 and above, 1 siya. No? This is 0.299, which means our model tells us that this person should be rejected. Pero tingnan natin, ang actual natin, na-admit siya. No? Okay, ano ibig sabihin nun? Mali yung model natin. No? So this is one error. No? May error tayo dito sa observation number 2. That's fine, kasi 325 naman isa-isahin natin yan, guys. Of course, we're not going to individually compute for the log odds ratio or for the probabilities. No? We're going to use R para mo-compute natin yan. But pause muna ako, guys. So far, clear ba tayo, no? Yung ginagawa natin sa binary logistic. So just to recapitulate, we have this equation, okay, y is equal to whatever your dependent variable is. Y is your dependent variable, and then we're regressing it on the independent variables. And the use of GLM there, family binomial, dun sa R natin kanina, indicates that your Y, the value of your Y is not your ordinary value as compared to your multiple linear regression. Yung Y natin is your log odds ratio. So whatever value you get for Y, when you compute it for each of the individual observations, you need to convert it kasi log odds ratio yon. It's so difficult to interpret what a log odds ratio. Okay, sige. Let's go here, guys. Let's go here. Ayun, no? Okay. So we're going to this is now the beauty of no of your R. Let's use the predict function. Predict function, and ano ba yung mod natin? Mod, sandali So let's just change this. Tama, ito yung mod natin, ano? Yan. So this is our mod object. Okay. So tama, andyan pa rin yung mod natin. Let me run this just to be sure na andyan yung mod natin. Okay. And then we go here. Yan. Of course, we're not going to compute each of the observations dun sa trained data set natin kasi matagal yun. Okay, so let's create this object called P1 and then we're going to use the predict function. Okay, the predict function, sige, again, ano natin, predict. Control Enter, tingnan natin sa console. Guys, aralin natin kung ano ba yung ginagawa ni predict. Here, also from the stats package. So the predict is a generic function for predictions from the results of various model fitting functions. So itong predict, pang LM yan, pang GLM, it doesn't matter. Kaya niya, no? Kaya niyang gawin kahit anong linear model, whether it's generalized or yung ordinary na linear model natin. Okay, so the model that we're going to predict is yung mod natin, di ba? And our data is trained. So what will happen? Di ba may model tayo, y is equal to? So i-predict niya yung mga y ng trained data set natin. And let's have it print the first, the first 10, no? The first 10. Okay, yung head function natin. So let's run this. Okay, there. No? So tingnan natin kung kayang round. Let's round. And let's see, kasi kahit 3 lang. No? Okay. Yan. Alright, para pinakote lang natin. Okay, take a look at this. Ito yung mga log odds, no? Diba? Naalala yung negative 9.33. Ito yung negative 8.51. You recall that, class? Ito yun. Asan yung si 8.51? Ito, no? Diba? Yung sa second observation to, 8.51. Then 0.767, then etc. Ito na yung first 10 observations. Okay? Ng predicted value. Okay? Based on the model. Okay? Now take a look at this. We now have P1A. Let's use the same predict, mod, train, and type is equal to response. And then, sige, let's generate also yung first 10. Okay. So here, ang create natin P1A. Okay, pareho lang yung syntax, pero may linagay tayong parameter dito. Type is equal to response. And then let's have it printed. Okay, so let's run this. Okay. So i-round ulit natin to. Round. Masyadong mahaba. Kahit 3 decimal places ulit. Okay. Take a look at this, class. Diba ito yung 0.28 kanina tsaka 0.299. Ito yung ito yung probabilities. Diba? So we can generate the probabilities for each of the predictions. Kinonvert na yung kaninang log odds into probabilities. Excuse me. Okay. So, all right. Let me pause for a while, class, and allow you to, maybe you're also following along, and allow you to study for a while kung ano yung difference itong dalawang to. Siguro ganito gawin natin. Sineparate ko siya. I separated the two so that we can print both. Sumobra to. Ito. First, ano na lang? First 6. Para mabawasan ng konti. Yan. Tsaka ito din. First 6 din. Okay. Okay. And then tell me, guys, what's the difference? What's the difference between yung isa, yung predict mod data is equal to train, and then yung pangalawa na may dinagay tayo type is equal to response? What's the difference? Anyone, guys? What's the difference between the two? Yung negative 9.33 at saka 0.282. One is expressed as, and the other expressed as what? Someone? Ano difference sila? Difference nito at saka nito. This one and this one. What's the difference between them? This is expressed as, class, expressed as ano siya? Hello, guys?
Naka-negative po, sir.
Negative. Okay, may mga negative at saka positive dito. Pero ano to? What are these? These are your
Log odds, sir.
yes, log odds ratio to, di ba? Log odds ratio. Mga log odds ratio yan. Ito naman, guys, ito na yung probabilities, di ba? Pareho lang sila. They're the same, no? They're the same ano. Kaso, sabi natin, yung log odds mahirap i-interpret. Di ba? This is difficult to interpret. How do you interpret negative 9.33? Pero yan kasi binibigay ng equation natin, yung result ng model natin, y is equal to something, di ba? When we substituted the values of the predictors, you get the value of y. And the y is log odds yan. Bakit, you might ask, bakit iba yung sa ano natin, LM sa multiple linear regression? Yung sa multiple linear regression natin, hindi naman log odds yun. Kasi, guys, we use the GLM. Okay? So yung sa model ng GLM, pag family binomial, yung y ginagawa niyang log odds yung result. Okay? So that's the difference. Remember, we're not using LM function, yung sa regular na linear model natin. Ang ginagamit natin, generalized linear model. And you have to use this pag logistic, binary logistic regression model tayo. Otherwise, kung gamitin yung itong LM, di ba kanina ginamit natin, hindi siya nag-work. No? So you'll have to use the GLM. Okay? So these are the same things, no? Only that from a from an analytical perspective, ito yung mas magandang gamitin, di ba? Ito, ang hirap kasi interpret nito, negative 0.933. Pero you need this in order to compute for this. Hindi naman natin mako-compute ng mga probabilities ito unless hindi mabigay sa atin yung log odds ratio. Now, the good thing is that sa R, okay, you can already predict. Pwede na natin mapapredict yung. Okay, so let me delete that first kasi naglolo ko tong clear ko muna to, no? Okay, so one good thing in R, pwede na natin just with this, no? Type is equal to response. Isama natin dun sa pag-predict. Ang ibibigay na sa atin yung probabilities na. Okay. So let's now create yung first 6 ton, no? So let's show i-round natin to para hindi masyadong malaki. 3 decimal places. Okay. So I'm going to print yung first 6 elements in 3 decimal places ng probabilities at saka yung admit ng train. We would like to compare. Compare natin kung saan tama, saan mali. Okay. Sige, tingnan natin to, no? 0.282. So 0 to, di ba? 0, not admitted. Ang actual, not admitted. So tama. 0.299. Okay, not admitted to. Yung according to our model, hindi siya matatanggap. Pero according to our model, natanggap siya. So mali ito. No? Diba? So, yung model natin nagkamali dito. Mali siya sa number 2. How about this number 3? 0.683. So this is greater than 0.5. So based on our model, matatanggap siya. Okay. True enough, natanggap nga. 1. So this is correct. No? Number 4. 0.129. So less than 0.5. So dapat, hindi siya ma-admit. Yung actual na admit to. So mali yung mali itong number 4 natin. Okay? I hope you're seeing, guys, what's happening here, no? Si number 6, 0.235. Dapat hindi siya matatanggap. Actual, admitted siya, no? So mali itong prediction natin. Number 7, 0.347, less than 0.5. So, hindi dapat ito matatanggap, pero natanggap siya, 1. Okay? So mali na naman. So for the first 6 elements, guys, ito tama to, no? Only 2 were correct. No? Only 2 were correct. 4 were wrong. So that's how our model fared for the first 6 responses. Of course, 375 naman lahat siya at 325. No? So we can generate all para makita natin kung ilan yung tama, ilan yung mali. Okay, so let me clear this first. Okay, so let's proceed. Okay, so we will now create what we call a table. Let's call it pred1. Pred1, and then take a look at our function if else. Okay, so di ba yung P1A natin, ano ba yung P1A? View natin si P1A. View P1A. Okay, ito siya, no? So si P1A, ito yung observation 1, 2, 3, 4. Okay? Tapos ito yung ano niya, value. Si 1.28 and then 0.299, etc. No? So si P1A is a vector consisting of all the observations from the trained data set and their corresponding p-values. Yan, 0.366. No? Tingnan natin sa trained data set natin, ano yung dulong-dulo. Okay, not admitted, not admitted. Si P1A natin, ang probability niya is 0.366. So tama, no? So tama. Now we're going to create an object called pred1. Kaya ano laman niya? Gagamitin natin yung if else, no? So si P1A daw, if it's greater than 0.5, maggagawa siya ng object called 1. Okay, otherwise 0, no? Otherwise 0. So sige, let's run this. Okay. So pred1. Let's take a look at pred1. Asan na si pred1? Ito. So it's a vector, no? Vector siya. Tingnan nyo guys, 0, 0, 1, 0, 0, 0, 0. So kinonvert niya lahat ng less than 0.5, ginawa niyang 0, greater than 0.5, ginawa niyang 1. So let's print this. Okay, first 10. Yan, 0, 0, 1. I-side by side natin siya dito sa ano, no? Sa head ng train admit. And let's take a look at 10, the first 10. Side by side natin to, no? Okay. Alright, so mako-compare natin, class, kung saan tama, saan mali yung ano, yung model natin, no? Okay? So, what have we done so far? So, kinompute natin yung model natin using GLM, and the model generated yung mga log odds ratio. Si log odds ratio, pwede ma-convert natin yan sa probabilities, no? So, we generated that object called P1A na consisting of probabilities, and then yung probabilities yan, kinonvert din natin into 0 or 1 based on this. Okay? So, we now have a table, pred1. Ilan laman yung ng pred1? Just to show you, pred1, 325. Yan, no? Ba? 325 observations. So that's 1-to-1 correspondence with your trained data set. Okay? So, sige. Okay, what did we do here? Okay, this is another way, guys, to solve it. No? So if you recall, si P1 natin is P1 is ano ba si P1 natin? Ito, no? Ito yung log odds natin. Okay? So P1 is just a vector lang siya, no? So dito, okay, ginawa ko siyang log odds. I created another vector called log odds. Pareho lang laman nun, ano? Tapos, what I did here was to get the odds ratio. So si odds ratio is just converting your log odds into odds. So kinuha lang natin yung exponentiation niya. Okay, so let me explain that kasi si log odds natin ganito, 'di ba? Log ng P over 1 minus P. Yan yung log odds ratio natin. Okay? If you get the exponential of this, you'll get the odds ratio. Kaya ito, the odds ratio is equal to the exponential of your log odds ratio. Okay? So yun yung odds ratio natin. So notice iba na yung mga numbers, no? And that's generated by getting the exponential of this. Bali tinanggal natin log dito. If we get the exponential of this, the log will cancel out. So yung P over 1 minus P, that's already your odds ratio. Okay? And then to get the probability, diba, it's equal to exponential of log odds over 1 over exponential ng log odds natin. Okay? So this is just another way, guys, to compute for your probabilities, no? Okay, but hindi ko na gagawin to kasi you can just check it for yourself kung Sige na nga guys, i-ano ko na nga to, i-run na natin to, no? Okay, so probability, asa na siya? Ayan, 0.282, 0.299, 0.683. Di ba ito yung mga ano natin, ito yung mga ito yung probabilities natin, di ba? Right? So this is just another way to lagyan natin another way to generate the probabilities. Lagyan lang ng notes nyo guys para hindi kayo malito no kung para saan to. It was just meant to show you that we could have also created the probabilities using this method. Okay, so this is another way, but we won't run that anymore. Just explore that for yourself. Okay, kaso guys, dito nag-create tayo ng object. Sige, i-run na lang natin to kasi dito magpa-plot tayo dito ng ano ng odds versus log odds just to illustrate no yung difference nila. Okay, so na-run na natin tong probabilities ano. Tapos dito sabi niya okay, pero ang gagamitin dito sorry okay. All right. Here, pagsama-sama natin, let's create this ay okay, I'm creating this object called D. It's a data frame and it puts together log odds at saka odds at saka probability. Di ba may ano na tayo? We already have this log odds data. May log odds na tayo, no? Ito yung log odds tapos yung odds at saka yung probability. And then let's put them together. Let's take a look at the first 6 observations. Let's run this. Okay. I-round na natin para hindi masyadong okay, so these are your these are your log odds, these are your odds, and these are your probabilities. Ito yung na-compute natin sa y. Ito naman yung kinonvert natin si y using e to the y over 1 plus e to the y. Ito yan. Yung odds is just the you just get the exponentiation of your log odds. Kasi ito yung log of p over 1 plus 1 minus p. Ito naman yung p over 1 minus p. Okay, so here let's just plot. Okay, we're using ggplot2. Okay, so ipa-plot natin si D, yung data natin si D, and then sa X natin yung log odds, at saka yung Y, yung odds natin. Okay, so let's just plot this. Okay, so ito yung plot ng odds ratio, at saka yung log odds ratio. So if you notice, what happens? When your log odds is increasing, okay, so odds also is increasing. So directly proportional si odds at saka si log odds. Okay, ito naman ang ipa-plot natin si odds at saka si probability. So let's run this. Okay. So what's happening here? Okay, so ano pa rin sila? Directly proportional pa rin, directly related. Pero as odds increases, no? As odds increases, the probability of it keeps on increasing but already at a lower rate. No? So pinakita lang natin dito guys yung relationship ng log odds, si odds at saka si probability. And then ito yung last one, no? Si log odds at saka yung probability. Ito kasi yung kinompute natin kanina, yung log odds. Tapos kinonvert natin into probability. So let's plot this. Sorry, hindi ko na madidiscuss yung yung concept ng ggplot2. Okay. So ito naman yung relationship ni log odds at saka ni probability. So habang nag-i-increase si log odds, si probability also increases. So the higher the log odds ratio, the higher is the probability. Okay. Then last, ito na yung last, no? Okay, ano yung inaano dito? Anong pinaplot? So first, we're creating this object, log odds 1. It's a sequence of number from -5 to 5 and then by increments of 10. Okay, so if we run log odds 1, so no, si log odds 1. So nag-aano lang siya, -5, -4.9, nag-i-increase siya ng 0.1. Okay? And then what we do is kunin natin yung odds ni log odds 1. So you recall this guys, to get the odds ratio, you just exponentiate si log odds. So we got odds 1 and then if you recall ito, may function tayo sa taas yung probability ni log. Ito yung function niya, no? Which is just p log is ng log odds 1 to get the probabilities. Yan. Tapos pinagsama-sama natin dito, data.frame, si log odds 1, si odds 1, at saka si probability 1. Okay? We created this object D1. Alright, then ito na yung plotting. Papakita ko lang class yung sigmoid sa inyo. So let's run this. Okay. There. This is what we call the sigmoid function. Okay? Ito yung probability. Ito yung log odds probability. Okay, that's why it's not, hindi pwede nating hindi natin pwedeng gamit yung LM model, no? Kasi ang ibibigay sa atin yan yung mga values ng log odds. Okay, kunyari ito, di ba, ito yung mga values ng log odds natin. So from -5 to this one. Ito naman from 0 up to +5. So we cannot use the LM function kasi ang ibibigay sa atin na answer will be mga decimal places eh. So paano natin mako-convert 'yon? Okay? So pag log odds class, you have this is what we call the sigmoid function. Okay. Nakita naman yung word niyan dito kanina, di ba? Ito, sigmoid, this one. Sigmoid function. And it's like an S curve siya. S curve siya. And this is the plot of your log odds. Log odds versus the probability. Kinonvert natin si log odds into probability. And it will look like this. Okay? So sa model natin, nag-cut off tayo eh. Diba? So below 0.5, ito na yung not accepted or 0, yung Y. Dito naman, accepted or 1. Okay. So ano lang siya, additional information lang, no? For us to know. Yung log odds pala at saka yung probability. Pag pinatalaga natin yan, it will really look like a sigmoid function. Okay. Okay, so let's go now here. Okay, now how did our model perform? Okay, the beauty about R is that we can easily come up with a table, okay, and generate what we call the confusion matrix. Okay, ano yung confusion matrix? The confusion matrix tells us kung ilan yung tamang ilan yung tamang na predict at saka ilan yung mali, no? Okay, sige, let's do that. Okay. Here we're creating this object called tab1 and then we use this function table. Okay? So yung table, i-identify ko ano yung x at saka kung ano yung y. Okay, if you recall, ano ba si pred1? Okay, sabi natin, give this si x-axis, lagyan natin ng pangalan, predicted. If you recall, ano yung pred1? Tingnan natin dito Si pred1, di ba ito yung yung odds ratio, yung log odds ratio na kinonvert natin into probabilities and then yung probabilities kinonvert natin into 0 or 1. Okay, kaya nga yun, 0, 0, 1, ito siya. 325 observations. Tapos si train naman, in particular si train, yung admit, ito lang, 300, ilan si train? 325 din. So ang sabi natin kay R, gawa ka nga ng table. So on the x-axis, andyan si predicted. On the y-axis si admit, no? Then mag-cross tabulation siya. So let's run this. Okay, take a look at this. Okay, on the x-axis, we have predicted 0 or 1. On the y-axis, okay, actually baliktad, no? So nasa x-axis or nasa rows na lang. Nasa rows si predicted, nasa column si actual. Okay, ano ibig sabihin ng 208? Interpret natin to. Kailangan natin ito maintindihan, ha? So, anong ibig sabihin nito? Itong 208 na to. Take note, si 208, predict siya na hindi ma-admit, di ba? And what happened? What was this 208 admitted or not? Hindi. So, itong 208 na to, this is the correct prediction. Tama ito. Kasi actually, hindi siya na-admit. Predict siya as hindi na-admit. And also this 29, ito. So yung diagonals, no? Diagonals. The diagonals are the correct prediction. Kasi predict siya na ma-admit, tapos na-admit nga siya. And then this off diagonals, ito, these are the wrong predictions, mga mali siya. No? Predict siya na hindi ma-admit, pero na-admit siya, yung 73. And then also this one, 15, predict siya na ma-admit, pero hindi siya na-admit. So ang tama dito, 208 plus 29. Correct predictions. No? Tapos ang mali, 73 plus 15. Okay? So this is the correct observation. Correcto. This is the wrong observation. Wrong prediction. Okay, so wait lang Let me pause, guys. Paki-chat nga muna kung okay tayo. Okay, good. Yan, very good. Very good, guys. Salamat. Okay, pero ilan pa lang ba nag-yes? Dalawa pa lang. Sige. Let's wait for the others to comment. Okay. All right. Thank you. So, clear ko muna. Okay, so very handy, no? Very easy for us. So, quickly summarize ko lang kasi pabahan ng pabahan ng mga steps natin, no? So, syempre from starting to upload the data, which we know very well also, then dapat yung mga dependent variable natin for binary logistic dapat factor 'yan, no? Kasi sa binary logistic regression, ang minomodel natin is technically a categorical variable, a factor. So in R, we should have converted that. And then pag nag-regress tayo, use GLM. Okay, hindi pa pwedeng LM. Dapat, recall lang dapat lahat ng mga categorical variables dapat na convert into factors. No? All right, then the model will give us yung log-odds ratio. Okay, but we don't need that kasi mahirap i-interpret. So we can print. Okay. We can also use R in order to generate a vector of probabilities, and then we can also convert this into 0 or 1, no? Okay, so that was easy to do. And then ang ginawa natin ngayon, nagpa-create tayo ng table. This is called a confusion matrix, no? Okay, where you put side by side yung predicted value at saka yung actual value. So that's called your confusion matrix. So sa confusion matrix, yung tama na predictions, yung mga diagonals, yung mali, yung off diagonals. Okay. So let's now compute for sum. So what are we doing here? I-add daw natin yung diagonals. Diag is the function for the diagonal ng table na to, tab 1. So pinapa-add natin tong 208 at saka 29, okay, divided by the sum of tab 1. This will give us the percentage ng tama. So let's run this. Okay, so 73% yung tama na predictions. So 208 plus 29 divided by the total of your table 1. Therefore, ang incorrect natin, guys, that should only be 1 minus 73%, or we can also use this 1 minus that ratio. So 27%. Okay? 27% yung wrong prediction natin. Okay? Now, there's a function, there's a package called caret package. Na-install ba natin to? Okay, hindi, no? So, paki-install natin yan, guys. So, library. Caret is a very powerful package used in machine learning. Caret. Yan. Sige. Okay, baka hindi nyo pa na-install. Hindi ko pa, kasi bago ano yata ito ng R. Install that package. Just let's install that. Caret. Okay. So, library ko na. Okay, paki-chat nga guys kung na-load nyo na si Karet. Okay, good. Okay. So once we have loaded it, pwede natin gamitin siya. Okay, I would like to encourage you guys to study Caret. No? So this is one of the most powerful tools sa machine learning, sa data analysis. Okay, but in this subject, well, we're going to still use it in another one, sa multinomial. No? Okay, so let's create this object, CM1, and then we're using the caret function to generate the confusion matrix. Now take note, di ba yung confusion matrix, how did we go about it? Nag-create tayo ng, we use the table, no? Nagpa-create tayo ng table kay R for the predicted at saka si actual. No? Now take note, guys, check nyo to dapat pareho silang size. Kasi kunyari nagkamali ka, no? Ang linagay mo dito, let me just show, no? Ang nalagay mo dito, dot. No? Now, si dot, it has 400 observations, di ba? Eh si pred1 mo, 325 observations lang yan. So if you're going to run this, okay, mag-error siya. No? Sabi, all arguments must have the same length. Okay, so just be careful about that. Okay. Okay, so let's run this now. Oops. Ano nangyari? Pred1. May go. Kasi. Sandali lang Tama naman to. Pred1 is 325. Train is, tama, di ba si train 325 yan? Yeah. Okay, so what's wrong here? What happened? Okay, sige. Baka
Sir, missing po yung actual.
Sorry?
Equals.
Ano, no?
May missing po sa pred1, actual equals train admin.
Sorry?
Nasa chat po, sir. Nasa chat.
Okay, sandali sa tab 1 kanina? Okay, sa tab 1 kanina, kanina what I wanted to illustrate here is that si pred1 kasi 325 observations to. Tapos pinalitan ko to, no, si actual ginawa kong is equal to dot, no? But we know that dot has, ito yung complete data natin 400 observations to, no? Si dot yan, no? 400 entries. So if you're doing a table, ito, na magkaiba yung dimension sila, mag-error to. So this is what I showed, no? So nung rinan ko to, nag-error siya. Kasi si dot, 400 observations. Si pred1, 325 observations lang. So kaya nag-error siya. Okay, so what I wanted to remind you was when you're using this, dapat pareho yung dimension nila. Otherwise, mag-error. Okay, so walang problem dito. Ngayon dito, bakit siya ba't hindi nagra-run to? Confusion matrix. So ito diretso yung confusion matrix, no? Okay, si pred1. Ito si train. Okay, tama naman to. Okay, so dali guys. Let me go to, i-run ko nga ulit yung pred1. Asan si pred1 natin? So, sa inyo guys, ano nangyari? Okay ba sa inyo? Nag-run yung yung confusion matrix? Comment please. Did this function run? Did this function run, class?
No, po, sir.
Sorry, hindi rin. Error din. Okay, bakit kaya? Si Pred1, 325 observations. Okay, ito. Error pa rin. Data and reference should be factors with the same levels. Train, admit. Same levels. Let's check. Huh? Baka may check natin yung sa help function yung confusion matrix. Mali yung spelling ko. Confusion. Confusion matrix. Okay. Correcto. So this is the confusion matrix, correct? Okay. Data. Data. Okay. Natin ito example na to. X tab. Saan ako nagkamali? Confusion matrix X tab. Si X tab is a table of predicted and truth. Okay, sige, let's use that function. So tab 1. Dito, this should be train. No? Train. Okay. Tab 1 is a table of predicted and train. Sige. And then confusion matrix. So I'm following the syntax here, class. Dito nag-create muna siya ng cross-tabulation ng predicted at saka ng truth. And then confusion matrix. Pwedeng, sabi niya, pwedeng ano daw, pwedeng yung tab 1. Sabi niya, pwedeng tab 1, yung tab 1 sa atin, no? Or pwedeng ano yung pareho. Okay, let's see. Dito may error. No? Okay. So CM2. Print CM2, let's see. Yan, okay. Alright. Medyo nagkaano tayo ng syntax dito. No? Okay, so ang ginawa ko, class, meron tayong table, di ba? Tab 1. It's a table of your predicted and your actual. So that's what I use here for the confusion matrix Okay, confusion matrix and of tab 1, which is a table of your predicted at saka yung actual. And then print ko si CM2. So this is our confusion matrix using the caret package. So aside from the usual, ito no, usual, kasi ito lang binigay sa atin ng kaninang table natin. Si confusion matrix ng caret package, may mga additional ano sila. Ayan o. Okay? So una yung accuracy, di ba? Ito yung tamang prediction. So that was 73% kanina, you recall? 73%. So may confidence interval niya, okay? So ang accuracy niya lies between 68% and 78%. 95% confidence interval. So ano tong no information rate na 0.68? Okay? Tapos may mga ibang measures pa, may kappa, may McNemars, may sensitivity, specificity, positive predicted value, etc. So maraming maraming measures na binigay sa atin. Now, I would want you to this coming Wednesday, kindly please look at this, no? So that on Wednesday, I hope you have already answers here. Madali nyo ito makuha guys sa internet, ano yung confusion matrix, ano yung measures doon, and how are this computed, no? Yung kunyari ito, let me start with this one. No information rate. No information rate. Okay, ano ibig sabihin niya, yung no information rate? So, you recall nag-cross tabs tayo dito kanina. So, ito guys, no? So, let's reproduce this. Control C. By the way guys, dito sa details, dito sa dito sa may help function, ito, meron tayong explanation dito, no? Yung sensitivity, specificity, prevalence, etc. You can also refer to this. You can take a look at this. Tapos ito yung predicted, ito yung reference. Event, this is 1, no? So medyo iba lang yung order dun sa atin. Event is 1, no event is 0. Okay? Dun sa cross tabs natin kanina, 0, 1. Saan na yun? 0, 1 siya. 0 muna tapos 1. Kasi na pala, Bob. Malayo na yan. Ito, no? 0, 1, 0, 1. Ito naman dito sa details dito, 1, 0, 1, 0. So just take note of this kasi may formulas yung yung mga metrics na to. So let me just illustrate itong no information rate, no? Ano yung ibig sabihin nun? So let me run the cross tabs again. Admit at saka si rank, no? Dapat data is equal to, dapat train data na to. So nagpapa-cross tab ako ng sa train data. Ay, ba't rank? Ay, hindi, sorry. Dapat predicted. Sorry guys, hindi ito Ito dapat. Ito na lang, ito. So, ito kasi yung predicted natin, di ba? Anong pinakamarami dito? Dapat yung population. Okay, so sandali Okay, sige. So, ito guys yung pinakamarami, di ba? Yung 208. What if, wag na lang tayo mag-model. Ang gawin na lang natin, ang prediction na lang natin, lahat sila hindi matatanggap. Okay, lahat sila hindi matatanggap. So what will happen now is that all your 325 predictions will be here, no? Dito siya. Okay, what's the point? What's the point, guys? Wag na tayo mag-model. Total, siguro hindi naman accurate yung model natin. Lahat na lang sabihin natin, i-predict natin na hindi sila matatanggap, no? Okay, so if everybody will not be accepted, yun ang prediction natin, ilan yung tama doon? How many will be correct? Ilan, class? Ilan yung magiging correct predictions natin? If we predict that all the applicants will not be accepted. Okay, bakit yun ang ano natin? Kasi marami yung not accepted. Eh, no? How much would be, what's the rate of, what's the nating predictive power of our model? Okay, sige, sagutin ko na, no? Ilan ba talaga yung hindi na-accept? Yung actual ito, 208 plus 15. Ibig sabihin doon, tama yung magiging predictions natin. Kasi hindi sila talaga naging predicted, di ba? Hindi sila natanggap. No? So 208 plus 15 divided by 325. Saan nanggaling 325? Ito yung size ng trained data set natin. Take note, ito yung predictions sa trained data set. Ha? Ito, yung confusion matrix natin. So if I run this, control enter, I'm getting 68.61%. Ito yun guys, yung no information rate. Yun, 68.62%. Which means that is it really worth it to create your model? Eh di kung hindi, di bilangin na lang natin kung ilan ba yung hindi natanggap. Then yung pinakamarami, bilangin na lang natin. Tapos yun na lang yung gawin natin prediction natin. Lahat sila hindi matatanggap, no? So what will now be the probability na na okay yung model natin? So bilangin natin lahat ng hindi natanggap, which is 208 plus 15. Ito, lahat 'to hindi natanggap. So kung i-predict natin na hindi sila natanggap, tama tayo dito, di ba? And then divided by lahat ng i-predict natin, which is 325, then that's your no information rate. Okay? 68.62%. All right, so I leave you guys to look at the other measures. Okay, we will discuss that on Wednesday. Paki-check. Dito makikita niyo yan sa natin, sa magpa-help tayo dito sa sa confusion matrix. Ayan, guys. Andiyan yung explanation. Tapos you might check, may mga samples dito, no? You may wish to experiment on that. All right, so we have a few more slides. Okay. So dito, ang gagawin natin ngayon dito na, itetest na natin. We're now going to see how our model will perform in the test data. Okay. Remember that the model that we generated came from your trained data set. Okay, kaya nga natin pinapartition to para hindi tayo mag-overfit. Okay, so that we can expose our model to new data that it has not yet seen. Kasi yung test data, hindi pa niya nakikita yan. No? Di ba may test data tayo? Yung test data natin, 75 lahat yun. No? So we're now going to use our model for the test data set. Okay? So, basing it on the the models, no? Let's create this object called P2, and then we're going to predict. This is our model mod, and then we're going to use the test data set na. Kanina train, no? And the type is equal to response. Ibig sabihin, igagawin na niyang 0 or 1. Then create this object pred2, where we convert lahat ng 0.5. Okay, yung sa type pala, probabilities na to, hindi 0 or 1. Sorry, probabilities to, no? Hindi siya yung log odds, probability siya. And then, i-convert natin si P2, pag greater than 5, di ba? Admit siya, otherwise 0. Okay? So let's print the first 10 elements. I-round natin to para hindi masyadong round to to just 3 decimal places. Okay? And then, i-print natin yung si test, yung admit niya, Okay, so let's run this. Okay. Ito na yung result, no? Ito yung result. Ito yung row number 5, 14, 16. Okay? Kasi si test data, di ba, mas konti siya. Okay? So, ang prediction, 0, 0, 0, 1, 0, 0, 0. Ang actual, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1. So, yung first three elements, tama. Yung fourth, tama. Yung fifth, sixth, seventh, eighth, mali. Yung ninth, tama. Yung 10th, mali. So, kita kagad natin guys, may mga mali din, no? Tsaka may mga tama. So once again, we create this tab 2 na tayo, no? Table. This time we're going to plot predicted at saka yung actual using test, test, no? Tab 2 and then here. All right. So take a look. Okay. 70% yung tamang prediction, 29% yung maling prediction. Okay? 70% or 71%. And we can, okay, pwede rin tayo mag-add, Control-Alt-I. Pwede rin natin gawing, okay, ano ba ginawa natin kanina doon? Dapat CM test. Confusion matrix. And let's see yung anong table natin. Tab 2. Okay, tab 2. You can also generate the confusion matrix for your test data set. Okay, tapos print natin, print CM2. Ay, wait, sorry. CM test pala to. Okay. So this is the result, guys, of the model for the test dataset. Anong si test dataset? Si test dataset, ito yung in-split natin kanina. Di ba? In-split natin si train at saka si test into two. Ano yung purpose? Para hindi tayo mag-overfit. Ibig sabihin ng overfit, ginagamit natin lahat ng data natin para mag-model tayo. Ano yung pag may bago na siyang pag may bago na siyang data na i-check, baka hindi na maganda yung maging result, no? So we have this complete data, yung data natin. Hinati natin siya, 80-20 yung ginamit natin using the sample. So we came up with the model for train, okay? And then we're doing now and see if our model will work for the test data set. Okay, it turns out class na kanina 73% yung sa train, ito 71%. Okay? Hindi naman nagkakalayo, no? 71%. So our model still works in the test data set. So ibig sabihin, okay yung model natin. Okay? And then you have this, okay, yung no information rate 67% plus the other okay, plus the other measures which I told you to look into. Ano ibig sabihin ng sensitivity, specificity, etc. Okay. Now, take note, di ba, ang ginamit natin, we still have a few more minutes. So, I'll just run this. And hindi ko matatapos to, class, pero pakitingnan na lang to. Okay? Tingnan nyo rin, next meeting, tatapusin natin to before we go to the multinomial logistic regression. Kasi yung logistic regression, ayun na yun no? Ayun na yung pag-ano niya. And this is already the model that you're going to use. No? So there's this function, samba, yung receiver operating characteristics, i-run natin to. Okay? If you don't have it yet, kindly install the package. Okay, yung PROC, receiver operating characteristics, no? I don't have time to discuss yung details na to. So this is another one of the things that you need to read on. Paki-research na lang guys ng konti kahit paano. Para next meeting, pag finalize natin discussion nito, mas na tayo, mas maintindihan natin. Okay, so here we're creating this cutoff. No? Cutoff, then we're using this ROC, receiver operating characteristics. Then response natin is equal to yung training data set natin, no? So ang ginagamit natin dito yung training data set natin. Predictor natin is yung mod, yung fitted values ng mod natin, yung model natin, regression model. So run natin to. Okay. All right, I have 2 more minutes. Let me. Oops. Maling cut-off ko. Underscore dapat. So ano yung laman ng cut-off? It's a list of 15. Okay. So meron tayong tinatawag na area under the curve, which is 68.75. Okay. So time na guys. So i-run ko lang to, no? I-run ko lang tong next two. Ito muna. Okay. So we'll discuss this next time. Okay. And then ito. Okay. So may sinasabi siya ditong ano, no? 33.67. So ano kaya yung 33.67 na yan? So last one, if I plot this. Okay. Take a look at this one, guys. Ito. And meron tayong ROC curve dito. Okay. So kindly read on about this. What is the ROC curve? What does it do? Tapos itong mga ano na to, itong mga functions na to, para saan yan? Okay? Para saan yung, run ko lang itong quickly na to, the best value of cutoff for classifier is 33%. Ibig sabihin, mas maganda kung ang classifier natin is not 0.5, no? Kasi yung 0.5 arbitrary yan eh. So what cutoff should we give to admit and not admit and admit so that mas maganda yung model natin? Okay? And then last ito. So time na. And then this last one. All right. So dito guys, it turns out na mukhang hindi naman totoo yung ano, yung ROC na nakita natin, ano? Kasi kanina 73% yung tama eh. Ito bumaba, 65%. Okay. So sige, no, we're going to finish this next meeting. It's already 11 o'clock. So thank you so much guys. Paki-review na lang ng konti ito, no? So that quick lang tayo next meeting dito sa remaining part ng ano natin, ng stop recording ko na, ng lesson, and then we go to multinomial.